Okay, page 7 and 8 of trig bookwork. The size of the larger angle of a rhombus is 120 degrees and the longer diagonal is 7 centimeters. Represent this information in a clear and labeled diagram. Find the length of the shorter diagonal. Okay, our old friend the rhombus. A rhombus, remember, is like a parallelogram except for all the sides are the same length. Okay. So it says that the larger angle of the rhombus is 120 degrees. 120 degrees. And it says the longer diagonal is 7 centimeters. So that would be this diagonal. It's 7 centimeters. And this is 120 also. Okay. So if a rhombus has two angles that are 120, then its other angles are 180 minus 120, so it would be 60. So like this whole angle here is 60. Whole angle here is 60. Okay. And then since it's like a symmetrical diamond shape, since the whole angle is 60, each one of these small ones is 30. Let's write that a little bit nicer. 30. Okay. And then it says find the length of the shorter diagonal. So that would be the length of, and I'm going to draw it here in orange. It would be that length there. So we could find that by, considering this to be like, two different triangles maybe. And so we're going to draw this half a triangle here. It'll look kind of like that. So the line in the middle is 3.5 centimeters because it would be half of 7. Okay, and then this angle would be 30, and this angle would be 60. And then basically what we want to know is how long the blue line is. So maybe the first thing we should do is figure out what half the blue line is. It looks like that wouldn't be too hard. So then we have this, and we know that this angle is 30, and we know this length is 3.5, and we know this angle is 60, and this of course is 90. So the blue line would be, let's see, so we'd like to make a trigonometric ratio using angle 30, length 3.5, and this unknown length here. Okay, so that looks like a tangent, right? Tangent of 30 is equal to x divided by 3.5. And tangent of 30, we can do on our calculator, tangent 30. And we have negatives. Oops, I need to put it in degrees mode. So now we're going to do tangent 30 again. Tangent 30, 0.577. So 0.577 times 3.5 equals x. So x is equal to 2.02, and of course the blue line is actually twice this blue line, so we would multiply it times 2, so it would be 2 times 2.02 would be 4.04. Okay? Alright. Number 5. In the diagram, PQRS is a trapezium. PQ is parallel to SR. Okay, those are parallel. PQ is 7, RS is 10, QR is 5, and S equals 90 degrees. Angle S is 90 degrees. Find the height PS of the trapezium. So we want to know this height here. So I think the easiest way to do this is to make it into a rectangle plus a triangle. So if we do that, we'll just cut it off right there. And then we can see that we have made a small triangle. And one side of the triangle is this distance here, which we want to find out. This is 5. And this part right there, that is equal to 10 minus 7 because that's the part that sticks out. So that's actually 3. And then now that we have 3 and 5, we should be able to figure out the third side. And we could do that with Pythagorean's theorem or with, yeah, I think Pythagorean's theorem is the best thing to do. And so we could say x squared is plus 3 squared is equal to 25. And that would be the same thing as saying x squared plus 9 is 25. When 25 is 5 squared, that's why we put 25 there. So x squared is equal to, and we'll subtract 9 from both sides, and that'll give us x squared equals 16, and x is equal to 4. Okay, so that's equal to 4. 3, 4, 5 triangle. Don't know if you remember that. So the height of PS is equal to 4. Next, find the area of the trapezium. Okay, so now that we have the height x, it's not too hard to do. This we know is 4, this is 7, and this is 10. Okay, so the triangle, or the rectangle part of it is just 4 times 10. Not 4 times 10, I'm sorry, 4 times 7. And then this triangle part of it here, let's see, that is equal to 3, 4, 5. So we could just say, okay, 1/2 times base times height is equal to 1/2 times 3 times 4, which is 12, which is equal to 6. So this part is equal to 6. 4 times 7 is 28. We just need to add those together. 28 plus 6 equals 34. So that is B. Okay? And this is A. What about C? Find the size of the angle SRQ. SRQ. SRQ is this angle here. Okay? To find that angle, especially now we know that each of the sides is 3, 4, and 5, we can use sine, cosine, or tangent. So do whatever you're most comfortable with. Let's do tangent. So we'll do tangent of this unknown angle R is equal to 4 divided by 3. So let's put that in the calculator and see what we get. 4 divided by 3. And then we're going to take the inverse tangent of that. Inverse tangent of that. And we get 53.1 degrees. R is equal to 53.1 degrees. Okay? All right. Number 7. On a pair of Cartesian axes, plot the points 3, 2, -1, -4, and -1, 2. Use the same scale on both axes. B is a point such that ABCD is a rectangle. Okay. Let's see. I would put it about there. Let's see. Okay. So put 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So one of the points is A. It's at 3, -3, 2. It's right there. Okay, that's A. Another point is C. It's -1, -4. So -1, -4. Okay, and the next one is D, which is -1, 2. -1, 2. Okay. Then, so we plotted all the points. Then it says to plot B on the diagram. Oh, we already plotted everything. Oh, I see. It's we haven't done B yet. The only thing we haven't done is B. They tell us that ABCD is a rectangle. So what's the missing rectangle vertex? Well, it looks like it's right there, right? That would make it a rectangle. Write down the coordinates of point B. Okay, well, it looks like it's x would be 3, and the y would be -4. Okay. And then it says write down the length of AB and BC. Okay, so AB would be 3, 2, 3, 2, 2, 3, -4. Oops. So it would be this line here. This appears to be 1, 2, 3, 4, 5, 6 long. So the answer is 6. What about BC? BC would be point 3, -4 to -1, -4. So it would be that line. So how long is that line? Looks like it's 1, 2, 3, 4. Okay. Hence, find the size of the angle that the diagonal of the rectangle makes with one of the shorter sides. Find the diagonal of the rectangle. Find the side of the angle that the diagonal of the rectangle makes with one of the shorter sides. Okay. So let's make it into a triangle here. And then let's say, okay, the angle that the diagonal makes with the shorter side. This is the shorter side, so it has to be this angle here. Okay? So let's redraw that triangle. It's like that. And then we just found that AB is length 6 and BC is length 4, and we want to find out the angle. Now it's pretty easy, right? We know the opposite and the adjacent, and we don't know the angle. So we'll make a tangent equation for that. We'll say tangent of, x is equal to 6 divided by 4. Okay, so we'll put 6 divided by 4, and then we'll do inverse tangent of that. Oops, messed up. Inverse tangent, and then we're going to go up and grab 6 divided by 4, which is 1.5. The answer is 56.3 degrees. Okay? And that was the answer to that one. Number 8. Now we're going to talk about angle of elevation and angle of depression, and this should remind you of the investigation we did to figure out the height of our building. Angle of elevation is the angle that we used when we figured out the height of the building. Now if you were on top of the building and looking down, then the angle from horizontal looking down, that would be the angle of depression. Okay. So find the angle of elevation of the top of a tree 13 meters high from a point 25 meters away on ground level. Okay, so angle of elevation. So we should have something like this, just like that triangle we drew for our investigation. I'm just going to draw a little tree here. Okay. Find the angle of elevation of the top of the tree 13 meters high, so this is 13 high, from a point 25 meters away. Okay, and so they're looking for that angle there. So what trigonometric function should we use, knowing that the vertical leg is 13 and the horizontal leg is 25? Well, it's opposite over adjacent, so it's tangent of A is equal to 13 divided by 25. And so A is equal to inverse tangent of 13 divided by 25. Let's use our calculator and figure that out. 13 divided by 25, and then we're going to take the inverse tangent of that. And we get 27.5 degrees. 27.5 degrees. Okay? The angle of depression from the top of a cliff to a ship at sea is 14 degrees. Okay, so 14 degrees. The ship is 500 meters from shore. Find the height of the cliff. Okay, so basically what they're saying is that this distance here is 500. And they say, what's the height of the cliff, which is that. Okay, I'm just going to color in the cliff so that you can see which part is the cliff. Okay, and then here's the ship here. Okay, so we have a triangle that we know that's 14 degrees, we know that's 500, and we don't know this. So can we make a trigonometric ratio with those? I think we can make tangent here. Well, tangent of 14 degrees equals the opposite x over the adjacent 500. Tangent of 14 degrees is tan 14. It's 0.249. So 0.249 times 500 is equal to x. So 125. Okay, so the height of the cliff is 125 meters. Last one. A man whose eye is 1.5 meters above ground stands 20 meters from the base of a tree. The angle of elevation to the top of the tree is 45 degrees. Calculate the height of the tree. Okay, well, the first part of this is actually very easy, and you don't even need your calculator. If you know it's a 45, 45, 90 triangle like this one, and you know that the bottom of the triangle is 20, how much is this vertical part? Well, remember, a 45, 45, 90 triangle has two equal sides right there. So if the bottom was 20, guess what? The vertical one's 20 also. Then you just need to consider, hey, I have the guy standing here. And this should remind you of the investigation when Kadal said, hey, we need to think about the fact that we are not lying on the ground to do this, right? So how would you correct for that? Well, the guy is 1.5 meters tall, right? So since he is looking, since his eyes are 1.5 meters off the ground, all you need to do is add 1.5 meters to your estimate. So instead of 20 meters, it's going to be 20 plus 1.5 meters, and it's going to be 21.5. That's it. Meters. Okay? And that's it for today.